Hello and welcome to the online Calc Prep workshop. My name is Sarah and I'm going to be walking you through a few topics which will be helpful for you when you start taking Calculus 1. I hope that you find this helpful and that you will be able to do well in your Calculus 1 class. This workshop is only meant as a review of topics which you should have learned in your previous math courses. This is not intended to teach you new material, but to help you jog your memory of what you have already learned. If you still need more help with any of these topics, consider doing some more review on your own. Some options for additional review include visiting review websites like Paul's Notes or Khan Academy, or visiting CAPS. You can also meet with a professor, either your past math professor or your new calculus professor. You can also use these resources once you're in calculus and later in life. As we go through each of the topics, I will give a brief summary of the topic and mention where it might be used in calculus. Don't worry if you do not know the calculus terms I mention. This is just to give you an idea of how you might use these topics later. Then, there will be a few problems for you to try and work for yourself. I recommend that you actually pause the video and try the problems for yourself. Math is not a spectator sport. You never know how you will do on the problems until you actually try. To start off, let's talk about equations. If we think of mathematics like a language, you could describe an equation as a sentence telling you that two things are equal. Often, you have seen equations in a form where one expression is set equal to another, and you manipulated both sides until you have solved for only one variable. An expression being a mathematical phrase that contains constant numbers, variables like x or y, and operators like add, subtract, multiply, and divide. A function is a special type of equation which can be graphed. In Calc 1, you will mostly see functions that only have two variables, usually x and y. The two most common ways that you will see a function presented will be in either point-slope form or slope-intercept form. For point-slope form, you plug in a point from the graph x, y, and the slope of the function. This form will be very helpful when you get into the section of Calculus 1 on tangent lines. For slope-intercept, you plug in the slope and the y-intercept of the function. Take a minute to pause the video now and try solving the following examples. Find the equation of the line between the points 1, 2, and 3, 4. We can start by finding the slope of the line. We can decide that the first point 1, 2 is x1, y1, and the point 3, 4 is x2, y2. Then to find the slope, we can subtract y2 minus y1 and divide by x2 minus x1. That gives us a slope of 1. For point-slope form, we can say y minus y1 equals m times x minus x1. We can choose either of the 2 points in this case, but for now let's try 1, 2. So we have y minus 2 equals 1 times x minus 1. Subtracting, we end up with y equals x plus 1. If we instead wanted to use slope-intercept form, y equals mx plus b, we would use 1 point to solve for b. So we would say that 2 equals 1 times 1 plus b, so b equals 1, and then we would rewrite the slope and y-intercept plugged in, so we would have y equals x plus 1. Either way, you get y equals x plus 1. Pick whichever method you prefer. 2. Write the equation in slope-intercept form. X plus 11 equals 10y plus 1. We typically write y in terms of x, so let's switch the two sides and write 10y plus 1 equals x plus 11. Subtracting 1, we have 10y equals x plus 10. Divide by 10, we have y equals 1/10 x plus 1. Equations is when you use two or more equations to solve for more than one variable. The general rule is that you need the same number of equations as you have unknown variables. So if you have two variables, you need two equations to solve both variables. Systems of equations can be used in calculus to solve differential equations. The two main ways to solve a system of equations are substitution and elimination. For substitution method, you first choose one of the equations and solve it for a specific variable. Then you substitute that variable into the other equation or equations, and repeat if needed until you have an equation which has only one variable in it. Then solve the other equation, which should now only have one variable. After that, you can plug the value of the variable into the first equation to solve for the other variable. For the elimination method, the goal is to eliminate variables in order to solve for each variable. We do this by multiplying a non-zero constant and then adding the equations together. Let's try solving this example using substitution. For substitution, we will solve one equation in terms of just one variable. So let's take equation 1 and solve it as y equals some function of x. So that's pretty simple. We'll end up with y equals 19 minus 3x. Let's take that and plug it into equation 2. So we have x plus 19 minus 3x equals 8. Solving that, we get 19 minus x equals 8. Adding 2x to both sides and subtracting 8, we get 11 equals 2x. Flipping the sides and then dividing by 2, we get x equals 11 halves. We can plug this back into either equation, but let's try plugging it back into equation 2. We get 11 halves plus y equals 8. Then subtracting, we get y equals 16 halves minus 11 halves, so y equals 5 halves. Our final solution would be x equals 11 halves and y equals 5 halves. Let's try this using elimination instead. Line up the two equations so that you have the 3x over your x plus y over your y equals 19 lined up with the 8. Then subtract the second equation from the first one so that you end up with 2x equals 11 and divide again so that you can see that x equals 11 halves. And then again, substitute back into the second equation, and you'd get again y equals 5 halves. So your final answer again would be x equals 11 halves and y equals 5 halves. Take a minute to pause the video now and try solving the following examples. We can complete this example using substitution. Let's solve the second equation for y. So we get that y equals 15 minus x. Plugging that back into the first equation, we get 3x plus 2 times the quantity 15 minus x equals 19. Then, simplifying that out, we get 3x plus 30 minus 2x equals 19. Simplifying further, we get that x equals negative 11. We can then substitute this back into the second equation, which we solved for y. So we get y equals 15 minus the quantity of -11, or y equals 26. So we get a final answer of x equals -11 and y equals 26. In this example, we compare equations to eliminate one variable. So we can put x minus 3y plus 3z equals -4 with 2x plus 3y minus z equals 15 together, and solve this using our elimination method to get 3x plus 2z equals 11. Then we can pair 2x plus 3y minus z equals 15 with 4x minus 3y minus z equals 9 to get 6x minus 2z equals 34. We can then take those two equations and put those together, having 3x plus 2z equals 11 paired with 6x minus 2z equals 34 to get 9x equals 45, which then gives us that x equals 5. We can then plug this into one of the other equations that only has x and another variable. Let's take 3x plus 2z equals 11 and plug in 5. So we get 15 plus 2z equals 11, or 2z equals -4, z equals -2. Then we can take the value of x and the value of z and plug them back into one of the original equations to solve for y. So let's take 2x plus 3y minus z equals 15. Then we get 2 times 5 plus 3y minus the quantity -2 equals 15. So we get 10 plus 3y plus 2 equals 15. So then we get 3y equals 3, y equals 1. So we end up with a final solution of x equals 5, y equals 1, and z equals -2. Inequality is similar to an equation, but instead of saying two expressions are equal, an inequality says that one expression is larger than, smaller than, or equal to another expression. There are a few rules that apply with inequalities. You are allowed to add or subtract a constant or variable, and you can multiply or divide by a non-negative number. You have to swap the direction of the inequality if you multiply or divide by a negative number, or if you swap the left and right hand sides. In calculus, these can be helpful in writing out domains or intervals. Take a minute to pause the video now and try solving the following examples. We treat inequalities much the same way that we treat an equation. So here we can just subtract 2 from both sides and get 3x is greater than 6. Since 3 is a positive number, we can divide both sides by 3 and end up with x is greater than 2. For this example, we can multiply all 3 of the sections by 3. So we end up with -6 is less than 6 minus 2x is less than 12. Then we can subtract 6 from all 3 sections. So we get -12 is less than -2x is less than 6. Then, since -2 is a negative number, we have to flip the signs, so we say that 6 is greater than x is greater than -3, and then to write in a traditional form, we'll flip all of that. So we say that negative 3 is less than x is less than 6. Again, on this problem, we're going to subtract 2 from all 3 of the sections. So we get negative 6 is less than negative 3x is less than 3. And again, since we're dividing by a negative number, we want to flip the signs, so we have 2 is greater than x is greater than negative 1. And again, to write in a more normal-looking form, we're going to write negative 1 is less than x is less than 2. One way of thinking of absolute values is the distance a variable would be from 0. In terms of calculus, we often use absolute value functions, which are formally defined as f of x equals a piecewise function, where x equals x when x is greater than 0, and x equals negative x when x is less than 0. This means that if the x you were plugging in was already positive or 0, you leave it alone, and if it was originally negative, you flip the sign and force it to be positive now. This can be made more difficult if the thing inside the absolute value is not just x. In that case, you find where the inside expression is greater or less than 0 and change the domains on your piecewise function. When you have an absolute value that's greater than some constant, you're going to split that into two pieces. So you're going to say that what is on the inside is less than the negative form, and what is on the inside is greater than the positive form. So in this case, we're going to have 2x minus 3 is less than negative 7, or 2x minus 3 is greater than 7. Working on the 2x minus 3 is less than negative 7, we get 2x is less than negative 4, so x is less than negative 2. Working on the other side, we get 2x is greater than 10, x is greater than 5. So we write that x is between negative infinity and negative 2, or x is between 5 and positive infinity. Since a number can't be both smaller than negative 2 and bigger than positive 5 at the same time, we say or. For this example, when you have an absolute value that's less than a constant, then you're going to make one chain, putting the negative on the left and the positive on the right, with the inside of the absolute value in the middle. So here we have negative 1 is less than x minus 3 is less than 1. Then we can add 3 to each of the three sections and end up with 2 is less than x is less than 4. Take a minute to pause the video now and try solving the following examples. For this example, we need to simplify what's on the inside of the absolute value first. So we'll get the absolute value of 21 minus 2y is greater than 13. So since we have greater than, we're splitting it into that two pieces. So we have 21 minus 2y is greater than 13, and 21 minus 2y is less than negative 13. So solving the greater than, we have negative 2y is greater than negative 8, y is less than 4. Solving the less than, we have negative 2y is less than negative 34, so y is greater than 17. So we say that y is either less than 4 or greater than 17. For this problem, before we deal with the absolute value, we're going to deal with that 2. So we can subtract the 2 from both sides and then divide both sides by -1, which switches the sign. So then we have the absolute value of x plus 5 is greater than 4. So again, we split this into 2 pieces and we end up with x plus 5 is greater than 4, or x plus 5 is less than -4. So then we have x is greater than -1, or x is less than -9.